one of these that we did called GeneSat. You can guess that measured gene expression in 2006. PharmaSat, which looked at pharmaceutical drug and dose response, that was launched in 2009. And the one I'll tell you the most about today is called OREOS. That's the organic and organism response to orbital stresses. That launched in 2010. The science got finished about a year and a half later. It's still up there in space. It'll be up there for another 18 years or so. It's in a rather high orbit. But this one disintegrated after 3.5 years. This one after about 2.5 years. When they come back to Earth's orbit and disintegrate, they completely burn up, with the exception of some little teeny titanium screws that hold on the solar panels. And they're really small. They're like 440 screws, maybe they're even 256 if you're a maybe you know what that means. Those are little screws. But if you ever see little tiny titanium screws lying on the sidewalk, they could be some of ours. But nothing bigger than that will fall on you from the sky that we put up there. Now, there's a lot of bigger stuff that falls out of the sky regularly, so don't worry about these things. The reason I say all that is just to emphasize we don't get samples back from space. Everyone says, oh, do you do the analysis in your lab? No. All the analysis is completely autonomous, all done in space. And the data come back, transmitted by a little bit of it on this little dipole antenna, which is tuned to a typical ham radio frequency, amateur radio frequency. And in fact, we publish on a website what that frequency is, and the ham radio operators around the world can tune into the little beacon signal that comes out every 5 seconds and get pieces of our data. And they can track the currents through the solar panels, the temperature of the satellite, and a whole bunch of other things that we basically publish in real time, if you will. The science data and the